All right, welcome to the Explainer. I am absolutely thrilled you're here today because we're tackling a notorious, massive headache for small machine learning teams, the model registry. Look, just hearing that phrase usually summons nightmares, right? You start picturing complex dashboards, messy S3 artifact stores, and server processes that literally need their own dedicated backup strategy. But what if I told you that you don't actually need all of that? Today, we're going to see how to build a custom, incredibly lightweight model registry from scratch in just a single weekend, entirely skipping the overhead of those clunky enterprise tools.
Okay, let's dive right into this. On one hand, you've got the heavy infrastructure demanded by industry-standard tools like MLflow. We're talking S3 stores, dedicated servers, constant maintenance. It acts as this massive operational tax on your entire team. But contrast that with the alternative, a lightweight, do-it-yourself solution using just FastAPI and Postgres. If you're a small team shipping, say a single ML product, that heavy enterprise setup is wildly out of scale with what you actually need. So today, we are hyper-focusing on that nimble weekend build solution.
Here's a quick look at our roadmap. We'll start by avoiding that operational tax, then map out the minimum schema, dive into dynamic JSONB metrics, discuss exactly when it's time to graduate to a bigger tool, and finally, lay out the specific build order.
So, Section 1, avoiding the operational tax and skipping that heavy infrastructure for a custom, lightweight approach.
The harsh reality here is that most machine learning teams reach for, and let's be honest, pay for heavy enterprise infrastructure years before they actually need it. The MLOps maturity model talks about registries like they're just one monolithic thing, but they aren't. Look closely and you'll see 4 totally distinct jobs hiding inside that term. 1. Tracking your training configs. 2. Storing and versioning metrics. 3. Mapping weights to database rows. And 4. Model surveying and A/B routing. The absolute crucial takeaway here, small teams only really need those first 3. Job number 4 is where the massive, expensive tools are in their keep. If you aren't doing complex model serving yet, those first 3 jobs, well, they easily fit into a single Postgres table.
Which brings us to Section 2, building the minimum schema. Just one single Postgres table.
Now, what's really interesting about this is how wonderfully minimal the core training job schema can be. Check out this lightly trimmed SQL Alchemy 2.0 table. Look at the columns. You've got your ID, the project ID, the version, a metrics column, which cleverly utilizes JSONB, and a model path. That's it. This incredibly simple table handles all of those core jobs we just laid out, with zero unnecessary complexity.
Let's actually zoom in on that model path column for a second, because this is key. It's intentionally defined as just a simple string. Why? Because it doesn't matter if your model weights are sitting on a local disk during development, stored in an S3 bucket in production, chilling on a modal volume, or resting in a Hugging Face repo. The registry doesn't care where the bytes live. It literally only cares that the database row knows exactly where to find them. This is what keeps your architecture delightfully flexible.
And we've got some brilliant, really user-friendly features baked right in here too. First, per-project auto-increment versioning. Let me tell you, calling models friendly names like V1, V2, and V3 is dramatically better for your end users than forcing them to stare at a giant wall of long UUIDs. Second, merging default configurations with user configurations. By merging a default config dictionary with whatever the user specifically inputs, the persistent config is always complete. No more doing archaeology 6 months down the line, desperately trying to guess what the default batch size was.
Moving on to Section 3, dynamic metrics with JSONB. This is how we handle the chaos of constantly changing metrics. So, I want to ask you a very direct question. How do you compare models that report totally different metrics? Imagine trying to compare a YOLO object detection model, reporting MAP50, right alongside an LLM fine-tuned reporting eval loss and blue scores. It is a complete structural mess. The old way of handling this meant using rigid database columns, which meant every single time someone trained a different model class with a brand new metric, you were forced into doing constant, incredibly painful database schema migrations. The new way? We just use JSONB fields. Because they're JSONB, those fields simply absorb new metrics instantly. It's totally free and requires absolutely zero database migrations. And this brilliantly illustrates the magic trick behind that concept. The Python logic here, specifically the _collect metric keys function, acts kind of like a vacuum. It walks through those JSONB blobs, collects every single numeric key that appears anywhere, and just returns a sorted union of them. The front-end UI then renders one table column per discovered key. It just leaves the cells empty dynamically if a particular model didn't happen to report that specific metric. Think about it. There's no separate metric registry table to constantly keep in sync.
The data simply tells the UI what to render. Okay, section 4, knowing when to graduate. Because yes, eventually, you will need to level up. In the spirit of radical candor, as your team grows, you absolutely will outgrow this custom tool. It's inevitable. So here is a clear timeline of 3 specific signals that basically scream it's time for an enterprise upgrade. Signal 1, multi-tenant RBAC needs. When your customers start demanding strict compliance about exactly who can read which artifact, an off-the-shelf role-based access control system is going to save you real time. Signal 2, blue-green or canary serving. When you need to route, say, exactly 1% of live traffic to a new version, a simple database row update just isn't going to cut it anymore. And Signal 3, automated CI quality gates. The very day your continuous integration needs to automatically refuse to merge a model based on metric regressions, well, you need a much heavier tool.
Now, to keep things completely transparent, we really need to talk about the honest caveats of this pattern, just so you don't fall into any pragmatic trapdoors. Number 1, and this is crucial, do not put heavy blobs directly into Postgres. Keep your model weights in external storage, not jamming up the database. Number 2, cross-project lineage tracking gets messy fast. If you start needing complex, sprawling graphs showing how models across 10 different projects all interact with each other, this minimal schema simply isn't built for that.
Finally, Section 5, the build order. Let's look at the actual execution plan to get this done. Let's move to how this actually builds out. Here is your incredibly pragmatic 3-step end-to-end build order if you're starting from scratch. First, you just create the SQL Alchemy schema we walked through earlier. Second, write those training endpoints and implement those clever configuration merges. And third, build out that dynamic JSON compare endpoint so your UI can do its magic.
200. That is the literal number of lines of FastAPI code required for this entire architecture. Barely 200 lines, plus one single Alchemic migration. The whole thing can be code reviewed in one sitting, and it runs right on the exact same Postgres instance your application is already using anyway. It truly, genuinely is just a weekend project.
So, I want to end our explainer today with a slightly provocative question, something for you to reflect on as you go back to work. Are you building for the scale you actually have right now, or are you building for the scale you've been sold? It is so easy to outsource our architectural decisions to whatever the popular tool category is. But remember, tools should fit the team, not the other way around. Thank you so much for exploring this with me today. Keep building smart, and I'll catch you on the next one.
If you found this helpful, hit subscribe and the bell so you never miss a video.